A buffer solution is made by adding 2.05 grams of sodium ethanoate to 1000 centimeter cube of 0.09 mole per decimeter cube of ethanoic acid. So you can see that's a weak acid and a strong base. What is the pH of the solution produced? So the buffer solution now is CH3COOH. And then you got the H plus CH3COO minus. This is the acid. This is a weak acid, but higher, large reservoir of weak acid. And this is a strong base. That's the base. That's large reservoir of the base. So write the Ka value for this. So the Ka value, so that's Ka. The Ka value is going to be concentration of H plus times the concentration of the base over the concentration of the acid. So that's the base, that's the acid. Apply. So if we apply or applying the Henderson-HasselBalch equation, and that states that pH is equal to pKa minus log of base 10 over concentration of the acid over concentration of base. All I need to do is find pKa to find the pH. I know the Ka, and I also need to find a concentration of the base because I've been given concentration of the acid. So let's find the concentration of the base. So to find the concentration of the base, I can say the base I have is sodium ethanoate. So that's CH3COONA. So in this case, I need to find the relative molecular mass of this base. So I've got 2 carbon. So a carbon is 12. So 12 plus 12 plus 3 hydrogens plus 32 oxygen is 16 plus sodium is 23, and that add up to 82 grams per mole. So that's a relative molecular mass of sodium ethanoate. Now to find the mole of sodium ethanoate, so mole is N over mass times over mass over relative molecular mass, which is the mass is 2.05 over 82. And so if I turn on the calculator, fraction key 2.05, arrow key down 82, and enter. So 1 over, that's fraction, but I need to convert that to standard to decimal. So press that, 0.025. So that would give 0.025 mole. So that's the mole of the base. Now I need to find the concentration of the base. The concentration of the base, concentration C for base, is going to be mole over volume. And the volume we're talking about is 1000 centimeter cube. And we know that 1000, so we know 1000 centimeter cube is equal to 1 decimeter cube. That meant that I've got my mole, which is 0.025 over 1, because it has to be in decimeter cube. and the answer will be, and that will be 0.025 mole per decimeter cube. So that will be the concentration of the base. So now I know the concentration of my base, and I need to find the pH. So to find the pH will be equal to pKa minus log base 10 of concentration of the acid, which we know that's 0.09, over concentration of the base, which is 0.025. All I need to do now is find pK. So I know the Ka is equal to 1.7 times 10 to the power minus 5. Therefore, pKa is minus log base of 10 times 1.7 times 10 to the power minus 5. And that will be equal to, so if I punch that into calculator, so with minus log 10 1.7 times 10 to the power minus 5 times 10 to the power minus 5. So that's 4.76955. So that is the pKa. Now I need to find put the pKa and find the pH. So pH will be 4.76955 minus, so now I need to put in the concentration for the ratio of the acid to base. So that would be log 10, arrow key, fraction key, 0.09, arrow key down, 0.025, enter. So that's 0.55 minus 0.5563025. So now to find the pH of the solution, I need to then take away that from that, and that gives 4.21. So that's how you use the Henderson-HasselBalch equation. Otherwise, you may have to just find the H plus. Once you find your H plus concentration using this, you know the Ka value, you know the concentration of the acid, you know the concentration of the base. Rewrite this equation. So you can rewrite this equation as H plus equals to Ka times the concentration of the acid over the concentration of the base. You know the concentration of base, it goes there. You know the concentration of the acid, it goes there. You know the value of Ka, it goes there. And you can find H plus. Once you find your H plus, then you say the pH will be equal to minus log base 10 concentration of H plus, and you should get 4.21. So that's another way of doing it if you're not using Henderson-HasselBalch equation.